Hello everyone, myself Yadagiri, Faculty of Basic Electrical Engineering, MLR Institute of Technology, Hyderabad. So in this session, we are going to discuss about the circuit element, that is a resistor, inductor, capacitor. So resistor is a energy dissipated element, inductor and capacitor are the energy storage elements. The concept is introduction to electrical circuits. So that is introduction to the RLC element, that is the resistor, inductor, capacitor. So these are the basic or fundamental elements. So we can use it to design the electrical circuits based on these fundamental elements only. So that is the first one is a resistor. So resistor is a physical property of the material, so which is used to oppose the flow of electrons. That is simply called as a resistor. So how can you represent this kind of structure means, let us take a material. So we would like to apply one battery or one source to the material, so that current flow path is going to be like this means. So there is a certain opposition or a structure to the flow of current here, that's why the electron flow choose this kind of path, and also here there will be opposition by this resistor and also choose another path, and also like this, and also like this means. So everywhere it will structure, that's why the flow of electrons are should be moving like this. So this is the zigzag path choosing the flow of electrons. So that's why this is a symbolic notation of the simply resistance or simply resistor. So resistance is nothing but it is a property of the resistance. Simply it's a property of the resistance. So it is denoted by the either capital R, or also we can sometimes represent by the small r, and measured in terms of the ohms. Measured in terms of the ohms. So this is the fundamental element in the electric circuit, that is a resistor. So it is the physical property of the material, so which can offers the opposition of the flow of electrons. So that is called simply resistor, and also it possesses the property of resistance. So we can represent the structure of resistance should be like this. It is a zigzag path flow of electron. So that's why we can represent the zigzag path flow of electron should be the representation of the resistance symbol. So it will always represent either the small r or capital R, and measure in terms of the ohms. So according to Ohm's law, so we need to write the first point of this one is voltage. Voltage across. Because we have applied some source here, we have connected some source here. So based on that, how much voltage taken by this resistive element that we need to discuss. So from Ohm's law, voltage across the resistor. Voltage across the resistor, that is V equal to simply I into R, that is the voltage drop across resistor also we can say. Next value is the current flow. So current flows through the same element, that is I equal to we can say simply V by R, and also we can say the power consumed by resistor, that is a P equal to we can write in terms of voltage and current, because it's electrical power we have applied. By the source we have to apply the electrical power, that's why the electrical power taken by the resistive element is a P equal to V into I. This is also one of the form. Otherwise we can also use the V keep as it is, instead of I we can write the V by R according to this one. So that this is the power dissipated by the resistor we can say, or power consumed by the resistor we can also say. The other form of the power taken by the resistor is, again we know that V into I. Then this case I as it is, instead of V we can write the I into R. So that we'll get the I square into R. So this is the first form of the power taken by the resistor. This is the second form of the power taken by the resistor. This is the third form of the power taken by the resistor. So whatever the formula you can use to get the power value, you can use that based on the requirement. So anyone we will get the same answer by taking the resistance of the, by taking the electrical power by the resistance. So next one is after this one. So we need to also measure the resistance of the material in terms of Ohm's law, that is R equal to V by I we can write. So that is volts. The unit of voltage is a volts we can say, and the unit of current is a ampere. Volts per ampere means the resistance of the any material either measured in terms of the ohms or also volt per ampere. 1 volt per ampere is also same as the 1 volt. So that's why these are the units of the unit of the resistance. And also after this one, there is a physical material formula, the resistance formula. So resistance of the physical material. physical material. Based on the physical parameter, that is the length and area of the cross section, we need to take one now the formula. So that is, so R directly proportional to the, we can say, L by A. Means based on this one, these two physical parameters also affecting the resistance value. That is, L is the length. L is the length of the material. Length of material. So in terms of meters, we can say A is the net cross sectional area of the material. That is the area of cross section of the same material in terms of the meter square. So these two parameters are affecting the resistance of the material. That is, one is the physical property or parameter, that is the length of the material can change the resistance value, and also area of the cross section also can change the resistance value. So and also one more property affecting the resistance of the material, that is the nature of the material. So nature of the material also so affecting the resistance of the material. And also one more is also there, that is the temperature of the material also can change the resistance value. So this temperature of the material also can change resistance value. So these four parameters are changing the resistance of the material. So based on this formula, we can write so that is R directly proportional to L by A. Then remove the proportionality, we got it the proportional constant as rho, then L upon A, where rho is the specific resistance. Where rho is the specific resistance. Also we can say resistivity of the material. It is a specific resistance or resistivity of the material. So how can you define the resistivity of the material? Means based on this formula only we have to define that rho is key capacity is, then the remaining parameters are simply taking the like a cross multiplication R into A upon L. So this is the resistance of the material, ohms measured in terms of, this is the area of the material we can measure in terms of the meter square. So this is the length of the metal measured in terms of meter. So finally we will get, the unit of this one is ohm meter. So based on this one, the resistivity of the material is nothing but it is a property of the material, means it is a resistance of the material. So which used to measure the resistance in the meter length, means it's the resistance of the material per meter length, that's simply called as a resistivity of the material. So resistivity is nothing but it is the resistance of the material per meter length, that's simply called as resistivity or specific resistance, because we have defined in the specific area, that is in the meter length, that's why it's simply called as the specific resistance, or also we can say resistivity. So both are same only. So this is the resistivity. Now coming to the next parameter, that is a conductance. Next one is a conductance. So it's also under the part of resistance, that's why we need to discuss about the conductance. So the conductance of the material denoted by the capital G. So it simply conduct the electron flow of the material, or it will use it to the flow the charge electron flow in the material. It used to accept or use it to supporting the electron flow of the material, that's simply called as a conductance. So in terms of words we can write is G equal to 1 by R, we can write. Means other words also we can define, that is reciprocal of the resistance, that's also called as the conductance of the material. So you can replace this resistance value as 1 key capacities, or instead of R we can take this formula, that is rho into L upon A we can take, then A upon rho into L we got finally, then G equal to A upon rho into L. Means the conductance we can measure in terms of here, the conductance we can measure in terms of here, that is a 1 by ohm. Also we have to write that 1 by ohm in terms of the ohm inverse, means the notation we need to inverse, opposite, that is we can get like a ohm inverse. Also we can write in terms of the words, that is a mho. So it is a unit of the conductance of the material. So this is either measured in terms of the ohm inverse or mho we can write. So in the symbol wise also we have a mho, that is this is the symbol notation of the conductance of the material, that is a mho. Next, from this one, this is a G equal to A upon rho into L we got. So here we can separate one term, that is a 1 by rho into A upon L, we have to write. So 1 by rho we can replace it as a sigma into A by L. That is a special letter, that is called where sigma is the conductivity of the material. Where sigma is the conductivity of the material. Where sigma is the conductivity. So G equal to sigma into A upon L. So finally, the conductivity of the material we can define, that is G into L upon A. The unit of G is a mho. The unit of length of the metal is a meters. So this one is meter square. Gets cancelled. Finally, we got that. Sorry, it is a mho or ohm inverse otherwise. So either ohm inverse. So this meter get upside, that is a meter inverse. I mean the conductance of the material measured in terms of, sorry, conductivity of the metal measured in terms of the meter inverse and ohm inverse and meter inverse. That is the unit of the conductivity. So which can define from this unit only. That is, it is the conductance of the material per meter length. That's simply called as the conductivity. Conductivity nothing but it is a property of the material. So that is the conductance per meter length, simply called as the conductivity. Or also we can say sometimes specific conductance. So specific conductance and also the conductivity both are same. Means it is the conductance of the material per meter length, simply called as the conductivity. So this is a complete analysis regarding the only the resistance. So and after that we need to move to the second element, that is the inductor. So inductor is simply called as it's a coil structure. So means take an infinite length of wire. So let us take a wire. So with the length finite or infinite length. So we need to twist into a coil. So by that it got a property to store the energy. That's why it is an energy storage element which can store energy in the form of magnetic field, and in this kind of inductor or coil does not allow the sudden changes in the current. If you are able to providing that kind of in condition to the inductor, so simply that would like to act like a open circuit. Means instead of stores energy, it would like to presenting the properties like open circuits. So that's why this is the main property of the inductor. Again, the inductor is nothing but it is a infinite length of wire twisted into a coil, so called as inductor. So and also it possesses the property of inductance. So it possesses the property of inductance, and which used to store the energy in the form of electromagnetic field. An inductor doesn't allow the sudden changes in the current. So we are able to provide in the condition like sudden changes towards the inductor, that would like to act like a open circuit. So this is the structure of inductor and this is the notation of the inductor. So we can measure the inductance of the material, inductance of the coil. Sorry. So in terms of the Henry, this is means this is the inductance or inductor of the any coil, and this is represented by the capital L and measured in terms of the Henry. Henry is sometimes measured in terms of the millihenry and also sometimes measured in terms of the microhenry. So these are the units of the inductor. So this is also fundamental element in the electrical circuit. So that is take an infinite or finite length of wire, twist into a coil. So that got a property to store energy. So that it is an energy storage element which can store energy in the form of magnetic field, and inductor does not allow the sudden change in the current. So based on that, if you are able to providing the sudden changes in the inductor current, so we'll get it like a open circuit simply. So the inductor, we can draw the structure like coil, like it's a coil notation. This is the structure of inductor, and also denoted by the capital L, measured in terms of the Henry or millihenry, sometimes microhenry we can write. So this is the inductor. So based on this analogy from the Ohm's law, how much voltage taken by this inductor from the battery or source, and how much energy storage. We are clearly claiming the inductor is an energy storage element. So I forgot to tell one thing. It is a resistor. So resistor take some power from the source, that is I square into R or V into I we can say, and also we can say in terms of energy. So this is a resistor only. So in the form of energy, the resistor can take the energy from the source, that is in the form of I square into R into T. But this kind of energy, the resistor doesn't store its turns, doesn't store in this zigzag path. Simply, it will convert that kind of energy in the form of heat. So based on that scenario, so the resistor is a energy dissipated element. So resistor is a energy dissipated element which can dissipate the energy in the form of heat. So the energy stored by the resistor should be equal to how much? Zero only. We got zero energy from the resistor. So that is completely converted in terms of the heat. So there is no more energy stored by the resistor turn. That's why it is a energy absorbed element or energy dissipated element we can say. Now coming to the inductor, so based on the same analogy, we need to do some analysis here. So that is we need to discuss the voltage of inductor means. So let us take inductor. We have already seen the structure of inductor is like coil. So after that we need to connect one voltage source to this inductor. So this voltage source to inductor, I mean to say some kind of voltage source is connected to the inductor. Then from that one, how much voltage taken by this inductor, that we need to discuss. So from Ohm's law, the applied voltage of the inductor, that is of V directly proportional to the instantaneous current, that is a change in current. How does it get the relationship to the inductor in terms of magnetic field? I mean to say we have to say the point of the inductor is it is a energy storage element which can store the energy in the form of magnetic field. So every current carry conductor so develop the own magnetic flux around that. So according to the altitude, that is, so that's why whatever the current supplied by the source towards the inductor coil, so based on that there will be a storage of the magnetic field. So based on that, so we can say it is an energy storage element which can store energy in the form of electromagnetic field. So from Ohm's law, we need to write V directly proportional to di by dt. So remove the proportionality, you will get L into di by dt. So that is L into di by dt. Means this is L is a proportionality constant. The L is a proportionality constant. So L is a proportionality constant, and also we can say it is a inductance of the coil. So it is a inductance of the coil. So we can say it is a proportionality constant, and also we can say inductance of the coil. So therefore, the finally this is the voltage we have got across the inductive element. So that we can say voltage across the inductor VL equal to L into so di by dt. Means from the source, from the energy source, the inductor can take the L into di by dt amount of the voltage from the source. This is the voltage drop across. We also say the point is the voltage so drop across the inductor is L into di by dt. So from this expression we also consider the current flow of the inductor. So that is V equal to L into di by dt. We know that. So some cross multiplication we have to do. So based on that, so di equal to we got it like V by L so into dt. So integrating on both sides. So need to do the integrating on both the sides. So we will get that is integral idi equal to integral V by L into dt. So here integration and differentiation are going to get cancelled. Finally, I equal to 1 by L integral V into dt. So this is the current driven by the voltage source towards the inductor. This is current through inductor is how much? 1 by L integral V into dt. Next, we need to find out the electrical power consumption of inductor. So that is the electrical power consumed by inductor. So that is P equal to we can write V into I. So this V I keep as this instead of V we can write this one. So that is a L into so di by so dt into I keep as this. So therefore P equal to L into di upon dt. So into I we can write this is the so electrical power consumed by the inductor from the source. Next we have clearly climbed the inductor is an energy storage element which can store energy in the form of electromagnetic field. So how much electromagnetic field stored by this inductor we need to find. That's why the energy stored by inductor. The energy stored by inductor that is E equal to integral P into dt according to the definition of the energy. So this P we have to write, that is this one, the L into di by dt. Into I we can write, and also there is a into dt. So this gets cancelled. So L comes out because it's constant of the coil, means its inductance of the coil is constant. So that we got finally I into di, integral I into di we got. So integration of I means it is I square by 2. So means L keep as this. So finally the energy stored by the inductor, that is half L I square. So this much of amount of energy stored by the inductor from the source. So this is the energy storage element. I mean, that is the inductor is the energy storage element. And the summary of the module is, summary of the session is, so till now we have discussed about the what is resistor, and the voltage drop across the resistor value, that is V equal to IR we got, and I equal to V by R we got, and the power dissipated by the resistor is a V squared by R, or also we can say I square into R. So these many things we have done about the resistor. And apart from this, also we have completed, or we have discussed about the resistivity of the material, and also conductance of the material, and also the conductivity of the material. So coming to the inductor, so what is inductor? Inductor is the energy storage element, and inductor doesn't allow the sudden change in the old current. So if you are going to make any sudden changes towards the inductor, so it should be act like a then open circuit. So this is the summary of the session. In the next session, we will discuss about the capacitor, that is a circuit element. So thank you one and all.